Alright, so in the previous video I made the player animations, and today I'm going to set up the player state machine, the scripts. So I guess I'll create at the root folder the state and also the state machine script. Reload. Okay. Let's create this two scripts. State machine. And here on the state machine, we need a reference to the state. That's the current state. I guess that can be protected. Let's just make private state current state. But now we need to create to work on the state class. This would be an abstract class, not a mono behavior. And I think maybe I can use interfaces, or I can just use virtual methods, and then I can just override. Yeah, I guess that's what I'm going to just make virtual methods. So public virtual void on enter state. You can just make, oh, it's going to be empty because every state can just override this. Public virtual void update. You can just on update public virtual void on fixed update, and also public virtual void on exit. Okay. We need also have a public. This would be a hash set of state, and also a function that returns a bool that says if we can transition to that state. That will be state transitions. Okay. That's good, and that will be get protected set. Okay. And now we can just create a new class. Let's just make actually let's go back to the state machine, and here I'll create a public void update state machine, and here will be current state dot on update public fix it public void fix it update state machine. Here will be current state dot on fixed update. And we also need a private void switch state. This will actually be yeah, it will be private, and need a state. Next state. Here we can just current state dot exit, and we can just switch the state, and then call the current state dot on enter. Okay, now you can just get a bool actually. Check state transitions. Here will be for each item in the current state dot state transitions dot item. Actually, we need to get this item dot item 2. That's the function. If item 2 is equals true, just return true, and then we return false, and we can just get a hash set. Oh, state and func. Oh, what? Wait, trying to explicitly tells the compiler what's this item. Okay, it's just state func bool. Okay, and here you can just get transition. For each transition, just check if we are allowed to get the transition, and then wait, it's not bool actually, it's a state. Return the transition dot item 1. That's the state. And here we just return no. And after update the state, we need to check next state is equals check state transitions, check current state transitions. If next state is not equals to no, we just switch the state, passing our next state as parameter. Okay. This will works. This will work. And I guess that's all we need for now. The current state, update state. Okay. Let's go back to Unity. We don't need this. But now we need to actually create the state machine. I guess this will be. This doesn't need to be a mono behavior. Let's actually. Let me see. We can. This is a simple game. We don't need a root state. We don't need to do a hierarchical state machine. So I can just, I guess I'll be just creating a scoop table object that contains the states and the transitions. Yeah, okay. Guess I'll create inside the state machine CS file, create asset menu, uh, public class, state machine info, I guess that's a good name. Let's try to create that. Oh, I forgot to inherit from script table object. Okay, create state machine info, and yeah, it needs to be a separated file. So I create a new one, state machine info. Let me just copy this. Wait, ENT recompile, okay. Alright, so after some time, I finally got some good architecture on the state machine. So I'm gonna show right over here. So these are the base scripts for all the state machines that I'm going to create. So I'm going to open the base state. It's a abstract class that contains state transitions, a hash set of state transitions, and the methods uh, that a state need to work, and the state transition, and this also a scriptable object. So the state transition is just a sealed class. A sealed class is just a class that can't be inherited. So right here, I got the state base. Like I'm going to switch to this state if these conditions, any of these conditions are true, and these conditions are also a scriptable object that just contains abstract bool method check transition. So let's go back here, and the state machine base contains the default state, the state machine states that contains all the states that the state machine is going to work. So all the states that you want to have in your state machine, you need to assign here on the states so that the state machine can initialize them right over here on the initialize states. And it's just a basic, it's not really basic, it's work well for, I guess, any size of the state machine. You can improve this by uh, adding hierarchical state machine, but this is just a single one. So right here, just reset the state machine, initialize the states, then update the state machine, check for transitions, and if there's any transition, just switch the state. Oh, right here. And right here on the check and state transitions, we check each transition, the state transition that contains all the states, and in all these states, check for the conditions, condition. And if we match the condition, if the condition is true, we just return the transition state. Else we return no. That's why we check right here if it's not no. Alright, so that's it for the base state machine. Right. So right here on the player state machine, we got the main scripts. Player state machine. Right. On the player state machine, we just inherit from the state machine base, and we got the state machine parameters that contains uh, everything that we need. Right now, it just contains the movement speed, but you can also add like jump, force, something like that. And it's also a scripted object and a sealed class because it doesn't need to be inherited. And this also is sealed. And right here, just override the initialize states called the base, but also initialize the player state, the player states, because we got this player state base that inherits from the state base, and is just a specialized version of the state base, but for the player. So you got the state machine parameter, and also this script. I don't know if I'm gonna keep this name, but it's just a crucial components that the states needs to work. For example, the transform, emitter, all that components. We just called base and initialize the states past the player state machine parameters right here and the crucial components. Okay. And right here, I just got one past state that inherits from the player state base. And just for testing purpose, I got the player transform using uh, the crucial component game object that's assigned to the player game object. So on the override, we can get all the components that we need. For example, here's the body. So we could cache right here, like I did the transform, and so that we can work later once we enter the state. So right here, just got one update method, uh, adding the position uh, to the player. That's a scripted object, and that's it. That's just a test state, but it works well. Let me show testing. Right here on the player, I got the player state machine, so we got the default state. That's the player test state. Got the state machine states that contains all the player states, just one, and all the parameters right here. Movement speed that is set to 5, right? And the crucial components, so just assign it here. Okay. I guess I'm gonna change this, but for now, let's just keep like that. And here's the states that contains the scripts and the scriptable objects. And right here, you can add the transitions. For example, you can transition to another state and add the conditions, but I don't have any right now. Yeah, and you can also set up the conditions using the same approach on the like I did on the previous state machine states, but that I'll do later. Alright, so for create a new state, we can just create a new script and then create state machine, player, states, and state states, more parameters. You can create another parameters because maybe you got one for testing, one for final release. But let's just press play. And as you can see, it's moving. It's updating this method right here. And if I change the parameter, you can see that it goes faster, slower, and yeah, that's how it works. All right. Uh, Reset this. Okay. Yeah, that's it. Um, that's the state machine. Um, it's not that complicated, but it works really well. Uh, Here's the transition condition phase that we can add new transitions. Just doing the same thing like the states, adding scripts and scriptable objects so that we can assign right here. Uh, so I guess on the next part, I'll be adding the movement state, the jump state, and the attack. I guess also the crouch and attack. That's for the next part. And I'll see you